Sir, good evening, sir. Very good evening, sir. Alappan, sir. Sir, we'll start in
Good
2
evening.
minutes, sir.
Yeah. Okay. Thank you.
Thank you. So, very good evening to all. Welcome you all to the fourth day AICTE sponsored faculty development program on key technologies enabling 5G. Welcome you all for the fourth day 7th session. So, today we have an eminent speaker. So, Dr. Annamalai Alagappan. So, actually, we would, sorry. So actually, we had a speaker of Dr. Srinath Das sir. So due to some unforeseen reasons, so sir could not able to join. So sir and Annamalai Alagappan sir collaboratedly worked together. So when sir asked Annamalai sir, sir readily accepted. Sir, we are very kind enough and very fortunate to have you for this session, sir. So now I request Mrs. S. Kalyani madam to introduce about today's session speaker.
Good evening, everyone. Myself, Monica Madam, Assistant Professor of ECE BITS Narsampet. I feel it's a great privilege and honor to introduce today's session keynote speaker, Dr. Annamalai Alagappan sir. Introducing sir with his educational details, sir finished his Bachelor of Science in the stream of Computer Science from Bhartiyar University, Coimbatore, Tamil Nadu in the year 1994. He finished his postgraduate certificate in higher education from Boto College, Gaborone, Northeast, Botswana in 2011. He done his Master of Science from Computing at Teesside University at Middlesbrough, United Kingdom in 2014. He also finished Executive Diploma in Cybersecurity and Master of Science in the stream of Cybersecurity at Mizoram University, Aizawl in the year 2022 and 23. He received his PhD in Information Security from Amity University, Jaipur, Rajasthan in the year 2023. Sir is presently working as Associate Professor at Southwest Minnesota State University, Marshall, MN, United States of America. Coming to Sir experiences, he worked as Head of the Department from 2019 to 2024 at Boto University, Botswana. He has 15 plus years of teaching experience. He had been module leader from 2011 to 2019, also worked as team leader, senior lecturer from 2008 to 2011. He was senior lecturer, senior technical trainer, senior software developer, and network administrator, web developer from 2001 to 2008 at Chennai, India. He also worked as faculty trainer, senior faculty, and proprietor from 1994 to 2001 at Coimbatore, India. His skills includes ethical hacking, network security, computer forensics and data recovery, computer networking, SQL Server, Linux administration, C++, machine learning, incidents response, complaints and governance, Python, web development, and Windows Server administration. Sir has 14 paper publications in reputed journals. Sir certified as ethical hacker from EC Council, certified as CCNA Cyber Ops from Cisco, certified as CCNA1 from Cisco Academy OU, also certified as Associate of Fundamentals of Digital Teaching and Learning from Blackboard. Sir also certified as IBM Big Data Engineer. I especially thank and welcome Dr. Annamalai Alagappan sir for sparing his valuable time and sharing your thoughts and being a part of our FDP. Thank you, sir. Thank you so much. Now I hand over the session to resource person, Dr. Annamalai Alagappan, sir. Thank you all.
Thank you very much, ma'am. So I'm much honored to be a speaker today. First, I would like to thank. Am I audible to everyone?
Yes, sir, you are audible.
Yeah, thank you.
Thanks.
Yep. Okay. So I'm much thankful to the to one and all from ECE department, Balaji Institute of Technology and Sciences, Waranga, for giving me this wonderful opportunity to present. Okay, this has been a very short notice to me. Okay, from Professor Das. Okay, so I had to come up with a presentation. Okay, in a very short period. Right. Okay. Yeah. Of course. Okay, I have done it now. Right. So today's topic is going to be on key technologies enabling 5G. To introduce myself, I'm Dr. Annamalai Alagappan. Okay, I'm currently working as an associate professor at Department of Mathematics and Computer Science, Southwest Minnesota State University, Marshall. I'm here in the US from mid of this year. Okay, so before that I was working with Professor Das. Okay, and I was the head of the department over there for almost close to 4 years. Okay, but my overall experience with both the university was 16 plus years. Right, that was my short introduction. So when we talk about 5G, right? Okay, first we need to understand what 5G is. First thing, we would have experienced our mobile devices connecting to 4G before, right? So sometimes you even now, okay, if you connect to 4G, right? Okay, if your 5G is not connected properly, or if you have a low connection, then you might see something called LTE on your mobile. I hope everyone would have experienced that. Okay, so what really it means is like it's running in 4G. Okay, so the primary difference between this 4G and 5G is in almost like 5 aspects. Okay, the first thing is speed. Okay, and then the latency, the capacity. Okay, and availability. Right. So these are all the things which impacts the difference between 4G and 5G. Okay, so we'll be discussing more on these things. Okay, and then the key technology. See, when we talk about 5G, it doesn't really mean that okay we'll be continuously working on mobile device, right? Okay, so it's not only talking about cell phones. Okay, it's all about latest IoT devices. Okay, so we have different technologies which is available, right? So out of that, when we come to 5G, okay, we have the technologies called millimeter waves. Okay, so we'll be discussing more on to that. Then we have small cells and massive MIMO. Okay, um, so we'll be discussing some of this to okay, it's not limited to these kind of technologies, but we'll be discussing on few of them, right? So what could be the impact on communication when we are using 5G? Okay, so it's like the main factor here is like the connectivity and the real-time data transmission. Okay, so it will be of very high speed. Okay, and then we'll have a reliable connection in the network, right? Okay, and then we'll be working on the real-time data transmission, which means, let's say, for example, if you are working on something, okay, it will be immediately transmitted with very, very low latency. Okay, so that's what they mean here, right? Okay, so first we need to understand what 5G is. Okay, so 5G is the 5th generation of mobile network technology, offering significantly faster speed, lower latency, and greater capacity than 4G. It enables quicker data transmission and supports a large number of connected devices simultaneously. We can connect as many devices as we can, right? Whereas in 4G, it's much difficult. Okay, so this advancement makes it ideal for high demand applications such as streaming high definition videos, okay, high quality videos, right? Okay, and then virtual reality, autonomous vehicles like Tesla and many other EVs that runs on the road, okay, and smart cities. See, now India is more focused on smart cities, right? Okay, so those are much feasible with the 5G technology. Okay, so that is one thing which we need to which we need to accept. Right. Okay. Right. So 5G technology significantly improves mobile broadband speed. Okay, along with faster downloads and seamless streaming. Right. So that's what I've been telling from the beginning. Okay, so the main thing is like it will be much faster. How faster it is? Like usually we'll be working on with 4G, we'll be working on almost like the maximum speed would be like 100 Mbps, right? But whereas in 5G, okay, we'll be looking at a speed in Gbps. Okay, so that's the main difference over here, right? Okay, so and even if you take the latency, okay, the highest latency or the minimum latency, okay, will be somewhere around 35 milliseconds in 4G, whereas in 5G, okay, it will be as minimum as 1 millisecond. Okay, so that's the latency in 5G. Okay, so it has a massive machine type communication, okay, so which caters to the IoT devices, right? Okay, so nowadays it's not only the mobile devices that we use, okay, we use a lot of IoT devices, okay. For example, if you take Google Home, Amazon's Alexa, okay, so there are many IoT devices that we are using, okay, and then even our refrigerators, okay, our microwave ovens, and many things are now connected to the internet, and then it works, okay. Even the air cons in our homes, the air conditioners, right? Okay, so that can also connect to the Wi-Fi, and then we can control it from our mobile devices or and even from anywhere, okay. So 5G enables massive connections between devices, facilitating the growth of the Internet of Things, okay. So ultra reliable, low latency communication, that's what I was mentioning. Like with 5G, okay, we'll be having a very, very low latency, which can go as minimum as 1 millisecond, right? Okay, so that's the minimum latency. Okay, so 5G offers ultra reliable and low latency communication, essential for applications like remote surgeries and autonomous vehicles. Okay, so see, nowadays there are electric vehicles which communicate each other. Okay, so that's a big research which is going on, and then we even have some kind of communications like that. Okay, so in that case, imagine like with 4G, if we have a low latency, let's say if there are two vehicles crossing each other, and then if they had to communicate because it's driving on its own, okay, there is no control, the human interaction or human control, okay. In such cases, what will happen is like they will collide, okay, if there is a latency, okay, if the vehicle that is coming opposite to one, if it is not communicating at a proper time, okay, then there will be a collision between them, right? Okay, so that's one thing which we need to work on. So 5G enables those communication faster with low latency, okay. And the surgeries nowadays, there are high researches which is going on remote surgeries. Okay, so in hospitals, if they had to do some critical surgeries, okay, there are specialists who may not come down to the location, come down to the place where the operation is going on, or to the operation theater. Okay, they might work remotely, and then they have to work on it, right? So in such cases, there should not be any delay. Okay. So that is again catered with this 5G technology. Okay. So when we talk about the 5G technologies, okay, I was mentioning few additional technologies, right? Okay, the first one should be millimeter waves. Okay, waves, right? So when it comes to millimeter waves, okay, so what we need to understand is like our smartphones and other electronic devices in our home, okay, which uses very specific frequencies on the radio frequency spectrum. Typically, those are under 6 gigahertz. Okay, so that's the normal frequency that we work on with our normal devices. Okay, but with 5G, we are working on a frequency between 30 to 300 gigahertz. Okay, and then it will be like a very shorter wave. Okay, not like a long wave, right? Okay, so that's why it's called as millimeter wave. Okay, so see with the normal frequency, right? Okay, so what we are facing is like we are starting to get more crowded. Okay, so in those cases, okay, because there are lots of devices which is connected to that frequency, right? So in that cases, okay, there will be like more devices, okay, and then we are going to experience a slower service on it, right? So in such cases, okay, if we come up with a different shorter waves, which ranges between 30 gigahertz to 300 gigahertz. Okay, it takes waves are called, these waves are called millimeter waves. Okay, so it can accommodate as many devices as it can. Okay, so because their wavelengths are measured in millimeters, making them much shorter than the wavelengths used in previous generation of mobile networks. Okay. So what are the advantages of this millimeter waves? It has a high bandwidth. Okay, so they provide large data transmission capacities, enabling ultra fast communication speeds. Okay, and secondly, it reduces interference. Short wavelengths result in limited propagation distance, okay, minimizing signal interference between devices. Spectrum availability, okay, that is another advantage. Okay, so they utilize underutilized frequency bands. Okay, because we are not using those frequencies between 30 and 300 gigahertz. Okay, so that is used over here. Okay, and reducing congestion in traditional communication bands. Okay, so it's not going to disturb other frequencies. Okay, that itself can accommodate as many devices as it can. Okay, then comes the high resolution, suitable for applications like imaging and sensing. Okay, and offering fine detail due to small wavelength. Okay, so the images that we work on, right? Okay, which will have high density. Okay, so just because it's high, it's using this small waves, okay, small wavelengths. Then beamforming capability is there for this millimeter waves. Okay, so that's one advantage which we need to accept, right? Okay, so that beamforming, okay, will be discussing it on a future slide. Okay. So when it comes to limitations or disadvantages, it has a limited range. Okay, so that's the main disadvantage with this millimeter waves. Okay, it cannot go as far like the normal frequency that we have now. Okay, so it's a shorter one. Okay, so that's one limitation. And then the second one is poor penetration. If there are walls, okay, so they cannot penetrate through walls. So they struggle to pass through obstacles like walls, buildings, and even foliage. Okay, so reducing signal reliability indoors and in urban areas. Okay, so there is some alternative solution for this. Okay, then we'll be discussing about it. Okay, so then the other one is like weather sensitivity. So for if it is raining, okay, or if you have bad weather, then of course there's going to be an interruption. Okay, so high susceptibility or to atmospheric absorption. Okay, so that is one disadvantage here with this millimeter waves. And again, it has a high infrastructure cost. Okay, so deployment requires dense networks of small cells. Okay, so we need to have. Okay, see, we are going to discuss about what is small cell is, but for now, what I'm saying is like we need to have more small cells to enable this. Okay, so it's just because okay we need to increase the availability, right? Okay, or you need to accommodate without any latency, right? So we need to use such so many number of small cells. Okay, so if we are not using this, okay, then it's going to increase the cost. Okay, so sorry, if you are going to use this kind of this number of small cells, okay, it's going to increase the cost. And the other one is like energy consumption. It's going to take more energy. Okay, devices and infrastructure for millimeter waves. Okay, communication may consume more power than lower frequency alternatives. Okay, the ones that we are using will use very lesser energy when compared to this millimeter waves. Okay, but of course, okay, these disadvantages can be overcome with other additions to the technology. Okay, so we are going to see one by one. Right. So as I was mentioning before, we are going to talk about the massive MIMO, small cells, network slicing, edge computing. Okay, so let me give you a small picture about what is a massive MIMO, a small idea about what's massive MIMO. Okay, first thing we need to understand, okay, what a MIMO is. Okay, multiple input and multiple output. Right. Okay, I think most of us are aware of uh, the communication, the two-way communications, right? Okay, so that's what here they do. Okay, so multiple input and multiple output. Okay, see, imagine like the towers what we have nowadays, the cell phone towers what we have nowadays. Okay, so it's a very big tower. Okay, it will be placed somewhere like within a specific range. Okay, maybe imagine like, okay, within 1 kilometer there is one cell phone tower. Okay, so each cell phone tower will have a kind of a dozen ports. Okay, so like 12 ports or maybe 20 ports. Okay, that's the maximum it can accommodate, right? And then that will cater to the connections that is reaching that cell phone tower. Okay, so that is the main disadvantage. Okay, sometimes you may be connected. Okay, you may have a proper connection, right? Okay, when we are using 4G, right? Okay, you will have a proper connection, but you will feel latency, or you may feel like, okay, your connection is not proper. Okay, you have dropouts. Okay, so there are many difficulties which we were facing with 4G. Now with 5G, each and every base station, okay, so that can hold more than 100 ports, okay, 100 and more than that, right? So which can accommodate as many devices that as it can, okay, or even it can cater to many ISPs, right? Okay, so that's one thing that we that is with the massive mining. Okay, then small cells, that is the next key technology that we are going to discuss about 5G. So when we talk about small cells, it's okay. Imagine like um, we are traveling on a car. Okay, so while we are traveling, we need to talk, right? Okay, we need to talk to someone, and then if we are on a call on our cell phone, we might feel some dropouts. Okay, see, let's say for example, if you're traveling, right? Okay, so it has to connect to one tower or it has to hop from one tower to the other. So when it is hopping, then you will feel a drop there. Okay, then on the other side, you may hear them saying that, okay, I did not hear you properly. Okay, so this kind of communication can be avoided using small cells. What do you mean by a small cell? Okay, imagine like there is a what is it? There is a bridge between two networks. Okay, so let's say for example, if you have a wireless connection at home, right? So you may have your wireless connection in one room at the corner, and then if you're trying to connect it from some other place, maybe on the corridor or somewhere, okay, then it may not connect. Okay, so it will have a very low connection or something like that. Okay, so what do we do? An alternative solution for that? We'll have a range extender, isn't it? So the range, see, this is something like we add many range extenders between these towers. Okay, so it can be installed. Okay, so it can be portable, right? Okay, it can be a small device which can be installed on on the lamp posts, okay, each and every lamp post, right? Okay, so you can see whenever people are moving, okay, it won't have any latency, right? Or it won't have any drops in the connection. Okay, so that is the advantage of this small cells. Okay, in the US, okay, they have come up with small cells in most of the main cities. Okay, then the other key technology is sorry. Okay, the other key technology with 5G is network slicing. So this is something like on one physical network, we slice that physical network into different slices, and then we use them for different services. That is the main advantage of this network slicing. Okay, so network slicing allows multiple virtual networks to run on a single physical 5G network. Okay, optimizing resources for different applications. Okay, so each slice can be doing different service. Okay, so that's the main advantage of this network slicing. Then the edge computing. This is something like, see, if we have a network, right? Okay, in our organization, in our workplace or something, okay, and we are connecting to some other servers, okay, which is outside the premises, right? Okay, so of course it's going to take some time to get information from there, isn't it? For example, if you take, okay, we have a Alexa speaker at home, right? Or we have Google Home speakers, okay, the smart speakers. If you try to ask some question, okay, it won't immediately respond, okay, it will take some seconds. Okay, so it's just because it has to go to the cloud, okay, give those instructions, get the answer, and then it has to come back, and then it has to respond to your question. It will take few seconds, okay, you may not feel it much, okay, but yes, of course, there is a delay in the response, okay. So these kind of delays can be avoided. Imagine like if you have every data at the end of your network, okay, so at the edge of your network, right? Then you can get it immediately, isn't it? Okay, so it can work on a real-time basis. Okay, so that's what is edge computing. So edge computing reduces latency by processing data closer to the source. Okay, so the source will be like virtually close to our network, right? So everything can be accessed very quickly, okay, without any latency. Okay, enabling real-time applications in 5G environments. Right. So I have given you a picture about like how massive MIMO is, right? Okay, multiple input and multiple output. So this is one picture that I would like you to give a focus on, right? Okay, so 4G ones doesn't have multiple ports. Okay, it will have a dozen port or something like that, and then it can accommodate as minimum as it can, right? Okay, and when it comes to 5G towers, okay, the one in the middle, you can see like there are multiple ports, and then it can accommodate as many devices as it can. Okay. So what are the advantages of it? Okay, it can have enhanced user capacity, right? Okay, so that's what I was mentioning, like it can have as many users as it can. So massive MIMO technology allows a base station to serve numerous users at once, okay, significantly enhancing user capacity. And improved spectral efficiency. Okay, so 4G spectrum, of course, okay, it's going to be slower when compared to 5G, right? So by utilizing many antennas, okay, massive MIMO technology improves spectral efficiency, optimizing the use of available frequency spectrum. Okay, so of course there will be a dense spectrum available in this massive MIMO. Okay, so that it can accommodate as many users as it can, right? Okay, advanced antenna technology. So this one, as I was mentioning before, okay, it can have multiple ports, and then the antenna is very advanced. Okay, so Massive MIMO employs advanced antenna technology to facilitate simultaneous communication, revolutionizing wireless communication networks. Okay. So the small cells, okay, coming back to that small cells again, right? Okay, so as I was mentioning earlier, small cells is something which can be installed in between the towers. Okay, so you can install as many as you want. Okay, even within the buildings. Okay, you can have a small cells. Okay, it's just some like a small router or something. Okay, which you can install everywhere so that it gives seamless connection. Okay, so it will have enhanced coverage, right? Okay, so small cells provide enhanced coverage in areas with high cellular demand. Okay, so wherever there are many users, okay, which may create some congestion. Okay, so in those places, if we have this small cells, then of course, okay, it's going to cater to many users. Okay, so ensuring reliable mobile connectivity. Okay. And capacity improvement. Okay, so they significantly improve network capability, accommodating more users in densely populated areas. Okay, and then a role in urban areas. Small cells are essential in urban environment where traditional base stations may be insufficient for service demands. See, the traditional base stations, what they are talking about is like the normal towers, okay, what we have, right? Okay, so it may not be sufficient, right? So what it does is like, okay, it will be something like a kind of extenders. Okay, small cells are something like range extenders. Okay, and then it can also capacity extenders, so it will increase the number of users. Then the other technology is beam forming. Okay, the best example what I can let you know about beamforming is like when we are driving. Okay, so when we are in a signal, traffic signal, okay, we'll be looking at the traffic signal. Okay, and then when it comes to green, we move forward, isn't it? So it's something like it is for us separately. Okay, it gives attention to, okay, virtually it gives attention to us, isn't it? So it's some, this technology is something like this. Okay, whereas if there is a signal which gives more focus on individual users. Okay, so that is what we call it as beam forming. Okay, so it creates a beam of a spectrum, focusing on each and every user individually. Okay, so that's what the main advantage of this beamforming. Okay, so directed signal transmission. Okay, beamforming focuses radio signals towards specific users. That's what I'm saying. Okay, so it will be focusing on particular individual users, enhancing the quality of communication. And reduced interference by directing signals. Beamforming reduces interference from other sources. Okay, so if you have focused communication, focused connection for a particular device, then there will not be any interference, isn't it? So improving overall signal clarity. Okay, so enhanced user experience. Beamforming leads to a better user experience by providing stronger signals and reliable connections. Okay. Then comes this network slicing. Okay, so as I was mentioning before, network slicing is like, imagine we have a one physical network, then we are slicing it like, okay, like pieces, and then we are allocating each one of them to different services. Okay, so that's what is network slicing. So there will be one physical network, and then we are slicing it into different networks, okay, virtually, and then we are providing it to different services. Okay. So it's okay. So that's what they say here. Okay. Virtual network creation. Okay. Network slicing enables the creation of multiple virtual networks, each tailored for specific services and applications. Okay. So each and every slice can look at a different job, different service. Okay. And then customized service. Okay. So through network slicing, operators can provide customized services that cater to the unique needs of different applications. Okay. So see, each and every application will work on different boards. Okay, it will work on different topologies, right? Okay, it will work on different networks, right? Okay, so in those cases, this will be much helpful, right? So we don't have to have different physical network for each and every applications or each and every IoT devices or something like that. Okay, so we can have one physical connection and then slice it, and then we give it to multiple services. Okay, so that's what is network slicing. Okay, and optimized resource use. Okay, network slicing optimizes resource utilization across applications, enhancing overall network performance and efficiency. Okay. Then we are talking about the edge computing. Okay, so again, to give us a short reminder of what we discussed before, like imagine like you have to get something from the cloud, okay, and then it will take a bit of time. Okay, it's going to have some small latency. Okay, so the example that I was mentioning is like when we talk to a smart speaker, okay, then it has to send information to the cloud and then get those information. Then we need to get it back, right? Okay, so in such cases, okay, it will have a bit of latency. Okay, so to avoid that, okay, we are coming up with a concept called um, edge computing. Okay, so reduce latency. Edge computing minimizes latency by processing data closer to the source, okay, and ensuring faster response times. Okay, and then real-time data processing. So in such cases, while we are using real-time, okay, while we are using edge computing, then what will happen is like whatever that we work, okay, you will feel like as if you are working on a real time. It won't have a delay. Okay, so if you are giving a request, immediately you will get those responses. Okay, and then decentralized data storage. Okay, so edge computing supports decentralized data storage, allowing for more efficient data management and access. So see, decentralization is a common concept. Like, okay, we don't have to rely on one particular source. Okay, we will decentralize it, and then we just separate them and then put it on a separate location where it can be accessed to whoever is more interested on that particular information. Okay, so it's basically like dividing the information on a one centralized server, okay, and then putting it into multiple locations. So that's what is decentralization. So that is the main advantage of this edge computing. Okay. And while we are bringing all these key technologies of 5G, okay, so what will be the impact? Okay, so this may sound like repeated information, but still, okay, we cannot avoid it, right? Okay, so of course, okay, it's going to have enhanced connectivity. Okay, so it can accommodate as many devices, including IoTs, okay, and then advanced technologies, right? So so it can accommodate as much as it can. Okay, so that's why they call it as enhanced connectivity. 5G technology significantly enhances connectivity, allowing for faster and more reliable communication across devices. Okay, and transforming industries. Okay, so of course, many industries are into online nowadays, right? Okay, and then they are working on different technologies, okay, different IoT devices, and they have, okay, everything is nowadays is internet based. Okay, so in such cases, okay, so we have the healthcare sectors, transportation, entertainment. Okay, so all these are nowadays have started to use 5G. Okay, um, so they have started using the 5G technology. Okay, so that they can enjoy all these efficient connections. Okay, And then new applications, right? Okay, so after this 5G, that's when we got so many IoT devices. Okay, with our older spectrums, we did not have this many smart devices in the world, right? Nowadays, everything is it has IoT. Okay, sorry, everything is into the 5G. Okay, and then there are so many devices which is evolved. Okay, even if you can see the robots to clean the rooms and places, houses. Okay, so they are nowadays using that. Okay, so which is again another IoT device. Okay, and then even our air conditions at home. Okay, that is a smart device now. Okay, and you can control it from anywhere. And then you have a smart bulbs, smart switches. Okay, there are many, so many, right? Okay, so any new applications, okay, it can cater, the 5G can cater to it. So with this 5G, okay, it has enhanced mobile broadband, right? Nowadays, everyone has an advanced mobile device in your hand, in your pocket, okay, so which can have faster downloads, right? Okay, so imagine something like downloading a HD quality movie in seconds, okay, in minutes, within a minute or so, okay. Would it be possible with 4G? No, of course not, right? Okay, so with 5G, we can download as faster as it can, right? Okay, and then improved streaming quality. Okay, so we don't have any latency. Okay, you don't see any stuck on your videos. Okay, so when you watch some videos in your mobile devices, okay, you don't see, if you have 5G in connection in your mobile device, then you won't see any delays in the videos. Okay, when you just click on that, okay, it runs smoothly. Okay, and support for advanced technologies. Okay, so 5G supports advanced technologies like virtual reality and high definition video transforming, enhancement, and communication. Okay, so any advanced technologies, right? Okay, so it can be supported with 5G. IoT connectivity. I was mentioning, like we nowadays we have lots and lots of smart devices. Okay, in our companies, at home, right? Okay, we have so many IoT devices. So with this 5G technology, it provides it works as if it's a backbone for IoT. Okay, so without this, the IoT devices won't be much efficient without this 5G technology. So the IoT devices will not be much efficient. Okay, so that is the one which is giving high speed to the IoT devices. 5G is the one which is giving high speed internet, high speed connectivity to the 5G, IoT devices. And when we talk about smart cities, okay, so even if you take India nowadays, okay, we are coming up with so many metropolitan cities which is becoming as smart cities, where this 5G is implemented. Okay, so 5G will facilitate the development of a smart cities, okay, enhancing urban living through interconnected systems and real-time data. Okay, and then connected vehicles. Yes, okay, so it's okay, it's still on research. There are many vehicles, the electronic vehicles or any moving objects, okay, that can communicate each other. Okay, so there are lots and lots of researches are going on that. Okay, and then for that to work efficiently, okay, 5G is the one which is helping it much. Okay, so so even if you take like two electronic vehicles, okay, imagine like two EVs coming each other opposite to one another, okay, and then if they can communicate, imagine what will happen. Okay, if they can communicate faster, which means, okay, it can understand that if there is a vehicle at the opposite, then I have to move aside, right? So if that gets delayed, okay, if the communication gets delayed, what will happen? There will be a huge collision, right? So that's the main advantage of this ultra reliable low latency communication. Okay, So it will be much helpful in autonomous driving. Okay, ultra reliable, low latency communication in 5G is crucial for the safety and efficiency of autonomous vehicles on the road. And then remote surgery. Okay, so I had even mentioned this before, right? Okay, nowadays the doctors can see, there may be specialists who will be busy on his location. Okay, and he may have to work. He may have to attend to a surgery on in a remote location. So such situations can be easily overcome with this 5G technology. Okay, ultra reliable, low latency communication. Okay. So in remote surgery, low latency communication ensures precise and timely actions, making it possible for surgeons to operate from afar. Okay. And then industrial automation. Yes, of course. Okay, every industry is working on their own automations. Okay, so they wanted to have everything. Most of their jobs needs to be automated, right? So 5G enhances industrial automation by allowing real-time control and monitoring of machines, improving efficiency and reducing downtime. Okay, so that's about ultra reliable, low latency. Okay. And as a conclusion, okay, I would like to highlight these three technologies, okay, like massive MIMO technology, right? Okay, massive MIMO technology enhances network capacity and efficiency, allowing for higher data rates in 5G networks, okay, and then small cells integration. Okay, small cells are vital for dense urban areas, improving coverage and enabling better connectivity for mobile users. If there are thousands and hundred thousands of users, okay, then in those cases, there is a need for these small cells. Okay, so there needs to be as many small cells as in urban locations. Okay, so as we can, right? Okay, so we have to install as many small cells. Okay, so it's something like a small device, okay, which can be installed everywhere. Okay, and then network slicing. So with this 5G technology, okay, network slicing allows for the creation of multiple virtual network on a single physical infrastructure. Okay, so if we have one single infrastructure, we can slice it and then we can capture it, we can use it for different services. Okay, so that's what they mean. Okay, optimizing the resource for different applications. Okay, so it can be used for, see, one physical network can be sliced and used for different application. Okay, in a short, right? Okay, so with that, okay, I'm coming to conclusion of my presentation. Okay, I'm happy to have any questions if you have. Okay. Thank you all.
Thank you, sir. Thank you for such a wonderful session. So, with a
Thank you.
short notice from Professor Srinath, you readily accepted, sir. So, very kind enough. Yes, sir. So, actually, instead of going for a specific topic, you have covered completely what are the technologies that are behind 5G. You have given a comprehensive overview of 5G technology, sir. Sir, actually, so you're working on cyber security like that, sir. How it can be played a crucial role in 5G? Can you tell us, sir, actually?
Okay, see, when it comes to cybersecurity, right, nowadays everything is online. Okay, of course there is a high chance of intrusions in each and every device. Okay, so even if you have a smart home, okay, you have a high chances of hacking onto those things. Okay, and then even cameras and everything, right? Okay, so of course we need to work on that part as well. Okay. So, see, we have been talking about 5G widely, but each and every section, if you take, okay, there will be a high chances of intrusions. Okay, so we need to work on that aspect, right? Okay, so that is one thing which will be related to the cybersecurity part. Yeah.
Most of us are doing some research, or most of us are faculty members, sir. Could you suggest some research topics to work on this area, sir? 5G and security, network security, like.
Okay. So really, what we can do is like enhancing the security. Okay, so maybe using some zero trust. Okay, so we can work on some zero trust technologies. Okay, so with all these IoT devices. Okay, if you take small networks, right? Okay, how we can enhance it with the zero trust. Okay, so zero trust is something like we don't trust any external or even within the network. Okay, we don't rely on until and otherwise if there is a proper authentication, okay, and individual authentication of each and every device. Okay, so there should be it should not allow, okay, any other users. Okay, so we can do some researches on these zero trust technology onto any of those new networks, okay, new devices, right? Okay, so that is one thing that we can work on. Yeah.
Thank you, sir. So participants, I'm requesting, so if you have any questions, you can
Yes,
ask.
sir, I have a query. Hello,
Yes.
am I audible?
Yes, sir.
Yes.
Sir,
Yes, sir. Yes, sir.
yeah. How can we take the concept of blockchain technology in this particularly D2D communication, preserve the privacy of a user to the authentication? Can we make any protocols for the D2D communication by having this some blockchain technologies? If yes, then within that blockchain technologies, like as you said now, zero proof or some other techniques. So please suggest that, sir.
Okay, see, blockchain technology, I'm not much aware of that. Okay, I'm still doing some researches on that. Okay, so I don't have a much knowledge about, okay, integrating blockchain technology over here.
Okay, sir. Thank you.
Any other questions?
Sir, I have one more query. Hello.
Okay. Yes, sir. Yes, sir.
Sir, in particularly, like basically, I'm working with D2D communication in 5G and its behind technologies. So, if so, how can we enhance the security in this D2D communication, particularly? Like, how can we preserve this authentication? Can you just suggest any techniques
Sure.
or anything? Like, we have certificate based or trust based or certificate less authentication.
Yes, sir. Okay. See, of course. Okay. See, the certificate based authentications. Okay, and then to enhance the security. Okay, you can work on the multi-factor authentications, right? With the different technologies. Okay, so not only with the traditional ones. Okay, so we can work on different aspects of multi-factor authentication. And also, even if you take the nowadays the passwords, okay, they are moving from passwords to passcodes, okay. So that is one thing we can work on, right? Okay, so we can instead of using passwords, okay. So because if you take the new artificial intelligence technology, okay, so there is a high possibility of cracking any passwords, okay. So in such cases, okay, we can go with passcodes. Yeah. So that's one thing that we can do.
So the last question I have, like now almost in some countries the 5G was deployed. So how 5G implementing 5G is that effective? Because in some airport areas still they haven't installed the 5G in some countries because of like the airplanes are unable to get some signals to get land or whatever nearby because of this 5G radiation. So what could be the effect of it, sir?
No, can you repeat the question? I didn't get it properly.
What, sir? What, sir? Hello?
No, can you repeat the question? Okay, I didn't hear it properly.
Sir, my question is,
Uh-huh.
like, in some countries, the 5G was installed, like in some areas
Yeah.
only, but not in everywhere. Like near
Mm-hmm.
airport areas, the
Mm-hmm.
5G was not installed because of problem like if there is some radius of this 5G, so the airplanes are unable to get signals like when the plane should be landed or runway when it should come or when it take off and all. So yeah, so does it affect, and if does, then what could be the solution? Like if does affects, then there may be a less chances of installing this 5G near airport areas. And however, that is also a kind of a drawback.
Okay, see, those areas like, see, even if you take the airports over here in the United States, okay, so you can see like this has been installed everywhere. The 5G connections have been installed everywhere. Okay, everywhere you move, you will see 5G connections over here. But for those areas and okay, where the flight signals and all those things, okay, where they have to prohibit those disturbances, okay, they'll have some kind of techniques where like jammers or something like that, okay, to avoid those communication, those 5G interruptions, okay. So that is something that they are implementing, that they have implemented over here, okay. So even okay, if you take any airports in the United States, okay, you can see 5G everywhere, okay, 5G connections everywhere. So yeah.
Thank you. Thank you.
Yeah, thank you.
Any other questions from participants? Okay, sir. So if they
Thank
ask
you.
any questions, I will forward it, sir. Sir,
Sure, sir.
could you
Sure,
please
sir.
share your PPT because participants are asking, sir, every day. So
Sure,
if you
sure.
share,
I'll
I
share,
will
sir.
forward
I'll send it. I'll send
Sir,
it
sir.
to the email that I have received. Okay, of course I'll
Yes,
do
sir.
that.
Yes,
Okay.
yes, sir.
Thank you. Thank
Thank
you,
you, sir.
everyone.
Thank you
Okay,
so
for
much.
your time. Yeah.
Thank you, sir.
Thank you. Thank you.
So, dear participant, next session is going to start in a couple of minutes. Sar is going to join. So, meanwhile, there is a there is a change in the schedule. Actually, please cooperate. So, tomorrow you will have session in the morning only, one session. Actually, we planned it for Professor Shillang Pan. So Sar was busy in some projects, so he suggested Dr. Vijay Kumar Mishra, who is a prominent speaker. Actually, he is working as a research scientist in Maryland University. So Sar accepted, but Sar is going to take the session in the morning only. He is having that time only free. So please kindly cooperate. Tomorrow first session is going to be at 10 a.m. only. Again, I will keep a reminder message in the WhatsApp group. So please support. Please, Sar is going to start. Please wait for a couple of minutes. Karthik sir, meanwhile, could you share session one today's session attendance link in the WhatsApp group? So
Okay, sir, I will
okay,
forward.
okay. So, dear participants, kindly fill the Google form. SAR is going to join in 5 minutes. So, next session will start in 5 minutes. Thank you. Dear participants, thank you waiting patiently. Sir is going to join just in 1 minute.
रिमोट रिमोट
So, welcome back to the next session. So, Sir has joined. Sorry, sir. First of all, apology for inconvenience, sir. So, during your busy schedule, so you are readily accepted for taking this session, sir. So, now I request Mrs. Madhav ma'am to introduce today's session speaker. Madam, over to you.
A very good evening to all. Myself Madhavi from EC department. It is my pleasure to introduce Professor T. Kishore Kumar Garu. Dr. T. Kishore Kumar Garu is currently professor in the Department of ECE, Head CTL, NIT Warangal. He obtained PhD degree in the area of signal processing in the year 2004. Dr. T. Kishore Kumar Garu headed the Department of Electronics and Communication Engineering, NIT Warangal, from 2015 to 17. He was also the head of Institute Computer Center, NIT Warangal, from 2018 to 20. He was a visiting professor for ESI JE LEC University in the France during the 2009. Visiting Professor Tallinn University, Estonia for the semester for MS Computer Science and Visiting Professor Asian Institute of Technology, Bangkok in 2019 under secondment of Indian faculty by MHRD, Govt of India. Prior to this, he worked as a technical officer in the Cabinet Secretariat, Prime Minister Office, Government of India. He is a member for the Central Counseling Board and member for the Andhra Pradesh State Council of Higher Education. He was also a member of E&ICT Academy NIT Warangal during 2015 to 17. He was awarded Best Engineering Researchers Award 2017, Best Engineering Faculty Award 2023 by NIT Warangal and NIT Warangal Alumni Association in recognition of his outstanding research contributions. He was awarded Research Excellence Award 2017 by Institute for Exploring Advances in Engineering. He was also received AEINMLC Academic Excellence Award National Level and the IEI Research Excellence Award National Level for the year 2023 by AEI Mumbai section. He received Best Paper Award for CNN-based lung cancer prediction paper in IEEE International Conference on Electronic Communication, Internet of Things and Big Data held at Taiwan in the month of April 2024. His current areas of research including signal processing, artificial intelligence and biomedical signal processing. He is a member of review committee constituted by RCI DRDO for reviewing a project worth of 160 crores. He has also completed 5 R&D projects funded by DSD DRDO worth of 1.5 crores and 3 projects worth of 1 crore ongoing. Under his able guidance, 14 scholars have been awarded PhDs and 5 scholars are pursuing PhD under his guidance. He has published 44 SAI journals and 40 international conferences during the last 5 years. Dr. T. Kishore Kumar Garu traveled across many countries like Australia, Czech Republic, France, Israel, Singapore, Dubai, Estonia, and Taiwan that contributed to his academic excellence. He has organized several faculty development programs in and outside NIT Warangal, coordinated MHRD, initiated GAIN courses, and developed several expert talks to DRDO, ECIL, and JNTH and another reputational institutions across the India. Dr. Kishore Kumar Garu is a senior member of IEEE ISTE and fellow ITE and senior member of IACSIAT. Thank you for giving this opportunity to introduce such a great person. Thank you all. Madhukumar sir.
Thank you, madam.
Thank you.
Sir, it's over to you, sir.
So thank you, madam, for giving the introduction. And first of all, I'd like to thank Dr. Madhukumar, head of the department, Balaji Institute, for inviting me to deliver a talk. In fact, just now I came home, and that too last week I'm totally busy. I went to Singapore and then Jodhpur for my project. Day only yesterday only I came, but with the request of Madhukumar and with his affection, so I thought to share my knowledge. In fact, I thought to give the artificial intelligence and applications in signal processing, but suddenly when I'm going through my slides presentation just now, I observed that one particular application where we focused our the application towards the healthcare with the MIMO, okay, multiple input, multiple output applications to healthcare, okay. So I will try to give some oversight view In fact, within a short notice, it is difficult, but just I will give the overview about those particular topics. So if possible, during the course of time, I will take the other session on machine learning and for signal processing. Okay. Shall I start, Madhu?
Yes, sir. Yes, sir. Please, sir.
Okay. So let me share my PPT. Is it visible?
Yes, sir. Yes, sir.
Yeah. So multiple input and multiple output in healthcare applications. Okay. So I will try to discuss this particular topic. So before going to see this particular multiple input and multiple output, so first of all, we will try to see about the evolution of the cellular network. As we are familiar with this particular the technology, the 5G enabled technologies. So I will try to give the insights about the evolution of the cellular networks. So when you talk about the 1G mobile networks were introduced in the early 1980s, and which are used analog signals for voice only services. Only voice, video is not there. 1G systems used frequency division multiplexing, multiple access, FDMA. As you know, different types of the medias are there. One is the time division multiplexing, frequency division multiplexing, and code division multiplexing. So based on these particular the transfer of the information, we are categorized these particular cellular networks. 1G, it is based on the frequency division multiple access. Coming to the 2G, which is introduced in the early 1990, and especially they are considered for digital versions of 1G networks. Whereas the 1G is used for analog signals, but 2G, which is used for the digital versions of 1G networks. And along with the voice services, they allowed the short message services. We can transfer the SMS and basic email services. And these systems use the code division multiple access, as I said, and TDMA principles. And the data rate, when you observe the 2G, it is the 14.4 kilobytes per second to bits per second up to 64 kilobytes per second. Whereas the 1G, it is offered data rates up to 2.4 kilobits per second. So these things are very much important. So even though we are talking about 1G, 2G, LTE, but people, they don't know about these particular frequency ranges. And when you go to interviews also, the immediately they will ask what is the difference between 1G and 2G, or what is the difference between 2G and 3G, like that. So as an engineer, you should have this particular idea. Now coming to the 3G, which are introduced in the early 2000s and were based on the GSM and CDMA. Okay, and these systems offer the first one is the only voice only. The second one is along with the voice, we can send the SMS as well as the basic email. But 3G, which will be used for web browsing and mobile phone, along with the voice, multimedia message, and support MMS and SMS services. And so these are actually these systems which include the Universal Mobile Telecommunications UMTS and WCDM. And when it comes to the bandwidth data rates, upward of 384 kilobits per second. So this is the clarification of the 1G, 2G, 3G. Now coming to the 4G, which are introduced in the early 2010s. The 4G networks offer data rates up to 100 Mbps and can handle more data traffic with the better quality of service. Okay, and which includes the applications like, what are the applications for 4G? Can anybody read 4G applications? Can anybody help? 4G networks include applications like
video conferencing.
Video conferencing. Are you not able to see? They have an access, Madhu.
Yes. Yes,
Yeah.
sir. We
Yes,
do
sir.
have.
Yes, sir.
So video conferencing,
Online gaming,
and
mobile
television. Okay. And these particular 4G systems include the worldwide interoperability for microwave access WiMAX and LTE, as well as LTE advanced. Okay. Now coming to the 5G, the 5G mobile networks are currently starting to be implemented. I aim to be 100 times faster than the current 4G networks. And 4G networks will offer data rates up to 10 gigabits per second, low latency and 100 greater reliability. So, as you know, the government of India recently, I think 2 months back, they have given the 100 the institutions they are identified for establishing the 5G labs. I think
Yes.
NIT Warangal we got, IIT Hyderabad, and different institutions across the country. They identified the 100 institutions and they provided the adapters and associated the 5G technology equipment to run the particular the system infrastructure. So then the 6G is the mobile networks are complete wireless networks with no limitation, unlimited. Okay. It is currently in the development stage and it will provide the incredible transmission speed in the terabyte range. Okay. So 6G networks will be self-free and it will be enable the artificial intelligence in the wireless networks. So quickly, so we can go back. So 1G, which are actually voice only service, 2G, which is the SMS as well as email service. The frequency, the data rate is 2.4 kilobits per second. 2G is 14.4 kilobits per second. 3G is 384 kilobits per second, and which is used for voice, multimedia message, MMS and SMS. 4G is the up to 100 the megabits per second, and which are used for online gaming, video conferencing, and mobile television. And 5G is the 10 gigabits per second, low latency in milliseconds, and greater reliability. And this particular technology can support many IoT enabled devices and smart vehicles. So this particular application where the technology can support many Internet of Things and enable devices, smart vehicles, which we can use it in various applications. Today, I will try to focus on the healthcare applications, how this particular 5G technology can be used. And coming to the 6G, it is upcoming field where there is no limitation and larger memory in cell phones and huge optical networks. These days, actually, when you heard about the Trump, the right hand, Elon Musk, anybody knows? These days, we're hearing
Yes,
about
sir.
Trump and Elon Musk. He is releasing a mobile phone. What is the specialty of that particular mobile phone? Anybody? Anybody, can you guess what is the specialty of that mobile phone that Elon Musk, the Trump right hand, he will be the the industrialist and he will be the probable minister in the Trump ministry in USA. So he is releasing one particular the mobile. I've heard about Tesla cars. He is the owner of that particular Tesla, and he is releasing the mobile which don't have any charging, and there is no need for this particular network. Everywhere it will work. So that type of advancement which are coming these days. Okay. So this is the evolution of cellular networks. Is it clear? Is it clear? Shall I proceed, ma?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So now coming to the mobile data traffic, as we have seen the connected devices as well as data traffic. If you see 2016, 2 billion per person, 2 per person. And when it comes to the 2022, 3.6 per person. That is the connected devices when it comes to the 2023 22, and the traffic rate, if you see, 9.1 gigabyte per month per person. So this is the order where the global mobile data traffic and growth in connected devices from 2017 to 2022. And when you see the evaluation of these particular cellular networks, 1992, 2G networks will be there, mobile phones, 2001, 3G, then 2011, 4G, and 2020, the 5G has come. So this is the communication from 1G to 5G. So factors which contribute more increments in wireless data, as you see, the broadband access, the 5G and beyond, they are used the different types of the in data traffic, where the 5G and beyond, which can be used smartwatches, connected stadiums, smart homes, smart cars, and broadband access, and cell phone and tablets. So now coming to the multiple input and multiple output. What do you mean by multiple input and multiple output? Okay. So can anybody read what is the definition of multiple input and multiple output? So this should be somewhat like interaction. I will ask, the people can help. So what is MIMO?
Multiple input, multiple outputs.
Multiple antennas are used at both source and the destination.
No. Please don't use your own words. Read what it is there on that. Okay.
So MIMO is an antenna technology for wireless communication in which multiple antennas are used at both the source and the destination.
Thank you. Okay, so then it is called the multiple input and the multiple output. So we can use the antennas both at the source and the destination. The basic purpose of these particular antennas at each particular end, why we are using not only the transmitting as well as the receiving the information, but at the same time which can be used to minimize the error, optimize the data speed, and improve the capacity of radio transmission, and enables the data to travel over many signal paths at the same time. So the importance of multiple input and multiple output for users is, as we have seen that, which can be used for high bandwidth communications, so above 5G and 6G, and it's frequently used by the first responders who cannot always rely on cell networks during a disaster or a power outrage, or when a cell network is overloaded. In such cases, the multiple input and multiple output is used for the users. So when it comes to the third generation partnership project, which is called 3GPP, added multiple input, multiple output with release of 8 of mobile broadband standard. And this particular multiple input, multiple technology used for Wi-Fi networks, cellular fourth generation, long-term evaluation LTE, and fifth generation technology, broadcast TV, and it is also can be used in wireless local area networks, WLANs we can use. So this is a new technology where we can use the multiple antennas not only for transmission as well as signal which we can observe at 5G as well as the wireless local area networks which we can use. And coming to the long-term evaluation applications of multiple input, multiple output, so which we can use the orthogonal frequency division multiplexers to increase the speed up to 100 megabits per second. And we can use these rates are double what was offered in previous the protocol. And we can use the transmit diversity, spatial multiplexing, okay, and single user and multi-user systems which we can use for LTE systems. And coming to the multiple input, multiple output and 5G massive systems, so to upgrade and to grow grow through its use in very new applications, as the wireless industry works to accommodate more antennas, networks, and devices. So that's why we are discussing today the healthcare applications where this MIMO can influence a lot. Okay, and another aspect, the MIMO and the beamforming. When you see, the beamforming is an RF management technique that can be used to maximize the signal power at the receiver by focusing the broadcast data to specify users instead of large area. So whichever the when you are using the band beamforming, different antennas, which particular antenna will possess the high gain, which we can use it, okay, as a specific user. Okay, so this is the beamforming where we can use the multiple input, multiple output, and beamforming. With when you see when with 5G, the three-dimensional beamforming forms and directs vertical and horizontal beams, and then these can be used for the high-rise devices. And this type of the application which we can use, the beams prevent the interference with the other wireless signals and stay with the users as they move throughout given area. So coming to the types of the multiple input, multiple outputs. There are two primary types of multiple input, multiple outputs. One is called the single user, another one is the multi-user. So in single user, multiple input, multiple output systems, data streams can only interact with one device on the network at a time. And multi-user means systems the outperform single user, multiple input, multiple output. But when it comes to the single user, multiple input, multiple output, many users attempt to use the network simultaneously. At the time, the problem will come that is called the loading effect. So if one person is uploading a video and another is conferencing, the data stream will choke, causing latency or delay to stroke racket. These days, we are observing when you are using the particular mobiles in WhatsApp also, when you are uploading a particular video or image, so you can come across this type of a problem that is called the single user multiple input, multiple output error will come. Okay. On the other hand, the Spectrum multi-user multiple output has the advantage of being able to stream multiple data sets to multiple devices. So these are the two different types of multiple input, multiple output types. And coming to the primary advantage of multiple input, multiple outputs in its various configurations, number of advantages over multi-input, single output and single input and multi-output. So multi-input, multi-output enables stronger signals. It bounces and reflects the signals. Video and other large-scale content can travel over a network in large quantities, and many data streams improve visual and auditory quality. So these are the major advantages of multiple input and multiple outputs. So how these massive multiple input, multiple output systems are influencing the future means, so the primary tool for advancing all aspects of wireless communication, it plays a substantial role in 5G technology, and it is influencing the users interact with these technologies. Okay, so they influence the multiple input, multiple output devices, high network capacity, more coverage, better the user experience. Okay, so you can see the advantage, the global bandwidth shortage in wireless communication sector, key enabling technology for next generation networks. So that's why this particular multiple input, multiple the MYMO, as your title of your workshop is the key enabling technologies for 5G. So this particular MYMO and beamforming, which is a key enabling technology for next generation networks. So the basic idea here it is the groups which groups together antennas at both transmitter and receiver to provide the high spectral and the energy efficiency using relatively simple processing. So simple processing in the sense that it only removes the error, it improves the bandwidth, and noise will be less. All these things which we can achieve with the help of massive multiple input and multiple output. So now we will try to discuss about the applications of, so up to now we have seen what are the evaluation of cellular networks, what is the multi-input, multi-output, multi-input and beamforming, and what are the different types, and what are the influencing factors, and what is the why it is called the key enabling technology for 5G. Now we will try to see the applications of MYMO in major various domains. Number one is the continuous monitoring of chronic diseases. Okay. So what are the different chronic diseases? Like this is the BP, sugar, so diabetic, all these things which we can call it as a chronic diseases. So routine checkups for most chronic conditions typically including the monitoring to check on the disease's progress. To build and create a continuous monitoring of chronic diseases, a 5G network is combined with mission-to-mission communication, that is M2M, and various these days we are observing variable device gadgets, a smartphone and a database server make up the continuous monitoring system. So the smartphone is connected to the server using 5G technology, and continuously it will monitor the chronic diseases. So here the artificial intelligence is used to continuously forecast the patient's state and determine whether or not the patient needs the medical intervention. If a patient becomes ill, this method allows them to communicate directly with a doctor over a vast distance. So this is the one of the application for continuous monitoring. You can see step one, the registration phase where the patient user. Okay. So then the step two, when you see the monitoring initialization, then trusted third party. Then step three is the authentication and key agreement medical IoT, that is called MIoT, medical IoT device. And then step 4 is the step 4a is the analysis of data. Step 4 is the upload the analyzed data, and the step 5 is the step 5a is the user request, 5b is the user request, 5c is the security of the material. So this is actually the cloud layer and users and device layer. So like this, what we are doing is we are trying to record this particular the electronic healthcare data, and we are trying to provide the trusted third party data, and which we can send it to the medical server, through which the cloud and the doctor will receive that particular information. So this is one particular application of the MYMU, that is the continuous monitoring of chronic disease. Okay, so this is the smart healthcare system and components. You can see the smart healthcare, where the network type, the local area network, MAN, WAN, and BAN. These are the different applications: glucose level, body temperature, okay, rehabilitation, ECG monitoring, oxygen saturation, blood pressure, healthcare solution. Especially this particular application, which is used in the during the COVID case, and the communication technology, short range and long range, and afterwards the characteristic, product oriented, semantic oriented, and application oriented. So like this, we can use the MYMO and the 5G technology to have the smart healthcare system. So these are the 6 steps are distinguished in this particular case. Okay, can anybody read what are the 6 steps are distinguished in this particular first application, MYMO and the health monitoring system, chronic diseases? What are the 6 steps? Can anybody read?
Register phase, monitoring initialization, authentication and key agreement between IoT and MEC mode, analysis data, user request, emergency situation.
Yeah. So these are the what you can say 6 steps that we can observe, and based on that we can process. So we can storing the information, that is authentication to doctors and patient information will be recorded. Then we can monitor the initialization, that is addressing the patients at particular intervals level over a particular period. So suppose if you want to know the HbA1c, 3 months data which we need to take, and we can encrypt the data for security and can be accessed with different types of keys. And then further we can analyze the particular data. Analysis means we can filter out whichever the noise which is present, collect and aggregate and interpret the data. And the user request, any user being patient or doctor with the correct access attribute, and which can be used for emerging users. The second one is the multi-input, multi-output in IoMT for digital health. Usage of MYMO means for the Internet of Things, MT communication, which we can use. So this is the digital health, which is transforming the healthcare, where the technological profession is opening opportunities to change the way healthcare. So why we are going for the digital healthcare, health promise, improve the patient experience, increase the quality of care, reduce the inefficiencies and costs. And digital health include telemedicine, remote monitoring via IoT, healthcare analytics, mobile health, and electronic health records. So these are the types of healthcare monitoring systems: health cyber physical system, okay, health oriented mobile cyber. The physical system plays a vital role in existing medical monitoring systems, and we develop the medical intelligent network system suitable for a long number of students, and we can create end to end delay of medical information and mobile health monitoring. Okay, so here a portable medical equipment and smartphone was proposed. Okay, so smartphones are used to collect the physiological signals of human body from variety of health monitoring devices by virtue of dedicated smartphone application software, and these signals are transmitted to medical centers, and if necessary they can also notify the caregivers and the medical emergency institutions using the short message service of mobile phone. So where the 5G technology which is available. So these are variable computing for health monitoring to know the SpOT and heart rate, health Internet of Things. Okay, then ambient assisted living, that is called the AAL. Then body area network based health care monitoring. BAN existing work on body area network focuses on sensor node energy, portable smart variable health monitoring system, and this is the common health monitoring the services as we have seen that providing the 24th remote ECG blood pressure real time the warning monetary abnormality short message will provide, then notifying the relatives of monitoring information, the emergency calling aid service providing like that GSM and the 3G technology. These are the things that we can communicate. These are the common health monitoring devices. This is the traditional medical devices and consumer devices are converging into Internet of Medical Things. Okay, and these are the connected medical devices empower new service models. So to have a awareness, exercise and activity trackers, prevention, behavior analysis, diagnosis, AI-driven diagnosis, virtual GP, treatment, and then management. And multiple input and multiple output in Internet of the medical treatment innovation. We have an IRA device, then Rapidos, then Graftworks. All these things, the variable gadgets which are there by using this particular multiple input, multiple output in IoT innovation. Third one is the healthcare systems and applications of MIMO and IOMT. Okay, so by using the embedded sensors, okay, variability, long working time, stability, low partition, degree of users, then processing data, interior storage mechanism. This is the physical exercise promotion and the smart clothing. So then healthcare robotics and mobile health cloud. So cloud computing is a new type of computing and service mode based on the internet. Through this particular mode, so pooling the hardware and software resources and the information can be supplied to the service. Okay, and through this particular cloud computing, we are sending the information through robotics and cloud assisted healthcare system. So this is the a typical healthcare monitoring system built with smart clothing and the backend cloud. So this is the physical data, cyber data, how we are doing. And this is the emotion monitoring system developed at UG University. A 5G cloud-centric the healthcare system. The concept of smart cognitive system is illustrated with the following features. Through 5G feature telecommunications technologies, sensors, cognitive devices interact smoothly. Then this particular networking is enhanced. So retrieval or access of stored big data, 5G networks which we can connect. The learning the data is the heart of conjugative computing, and conjugating the cognitive computing requires wealth of data available through cloud computing. A 5G cloud-centric healthcare system. There are three layers: first layer, second layer, and third layer. This is the architecture of a smart cloud IoT 5G based cognitive system. Okay, edge cloud, remote cloud, and edge cloud. So based on that, we create an architecture which can be used for healthcare monitoring system, where the cloud, IoT, and 5G based cognitive system. So these are the 5G use cases. As everybody knows that Industry 4, digital economy, digital India, smart health, smart governance, skill development, smart agriculture, smart entertainment. Okay, so from that you can observe the 4G and 5G. So 5G and healthcare. Just now we have seen these particular things. So variable and internet of medical things which we can get. So we can transmit the real-time patient health data to doctors. According to Anthem, 86% of doctors say they increase patient engagement. Telemedicine. You can see 5G and healthcare. So language translators will be able to video conference with the patient and doctor using models at the network edge. LSTM models, robotics autonomously or semi-autonomously performing the medical procedures, and a better leverage artificial intelligence tools and a better access to more specialists for collaboration. So robo will do the surgery by having these particular the language translators. So the 5G plays a crucial role in future and digital connected India. You can see the 5G enable these use cases based on its superiority, smart agriculture, smart manufacturing with high speed, low latency, connection density, smart care and telehealth, smart energy and utility, smart city, and smart education. So in all these cases, the 5G will play the crucial role in terms of high speed, low latency, connection density, reliability, energy savings. So these are the issues, the research challenges which can be investigated end to end the security. So as a summary, you can see that multi-input, multi-output along with IOMT provides a platform that creates opportunities for people to connect these devices for continuous remote health monitoring, which in return will promote efficiency in performance and economic benefits. And it's the most important development of 21st century. Okay, so this is about the what we can say the the multi-input, multi-output, and its applications. Okay, so now it is time for you, so you can interact. Out to Madhu.
So, thank you, sir. So first of all, I would like to say sorry for during your busy schedule causing your inconvenience, sir. So, and even despite of your busy schedule, you have taken some time for this session, sir. So, very grateful to you, sir. So, can we have some questions from participants?
So in fact, I could not get this just now. I have seen in my presentations. I observed that this is the 5G application, so that I want to share. Otherwise, I thought I told you, na,
Yes, sir.
AI
Yes,
and
sir.
its applications in signal
Yes,
processing. I thought to talk,
yes,
but
sir.
when I am scrolling these particular talks
Sir.
earlier, I have some particular material. Then I thought this is suitable because those who are doing the research
Yes, sir.
definitely it will be useful. And just now, actually, I met Dr. Srinivas, sir, cardiologist. So I
Sir.
went there. Tomorrow is the deadline. We are submitting a project for
Yes, sir. Yes, sir.
the Department of Biotechnology, where
Sir.
we are developing the system on chip for cardiovascular the diseases.
Sir,
So
sir.
where this particular the 5G application which we are implementing in fact just now I discussed with doctor also. So there is a lot of research scope which is available. So anybody who want to pursue research in this direction, not only that, AI in medical image processing, you are welcome to discuss. So you can go through my mail ID or you can contact Dr. Madhu. So you can interact. So any doubts?
Sir, could you suggest some research proposals because most of you are from faculty communities so that they can work out on that? So
Yeah, so there are actually now, as we have seen that the 5G in its applications in medical diagnosis. Okay,
sir,
so ultimately this is actually we need to take some particular data related to any type of application. Then we need to predict this particular data, we will apply some machine learning algorithm, and then we will try to send the cloud. Okay, the technology what we are using, either 5G or 4G or whatever maybe, to enable this AI and IoT through cloud and to create some particular, what we can say, the monitoring or alarm. So definitely these type of technologies which will be useful when you want to do in this particular direction. Otherwise, to predict or detect up to the data set and AI technique, and we can detect the particular disease. There are a lot of the areas which are there. Now, I don't have patience, energy, okay, tired.
sir,
Actually, next time, definitely, if anybody interested specifically, ask them to contact me. So
sure,
definitely I can help.
sure,
Okay,
sir.
ma.
Thank you so much, sir.
Welcome.
Thanks.
Okay, ma.
Okay, sir. Okay, sir. Okay,
Thank you.
thank you. So, dear participants, as I mentioned just earlier, so please please join the session at 10 a.m. tomorrow. Tomorrow morning 10 a.m. going to be the next session. So kindly cooperate. So next, our Karthik sir will share the Google Form link in your group. Kindly fill it and please try to join because tomorrow is the session by Dr. Kumar Vijay Mishra, who is a eminent speaker who is working in Maryland University as a research scientist. So please join tomorrow morning. I will keep a reminder message. Thank you. Thank you, everyone.